I don't know if anyone's still there. Sorry, I lost internet. Um, so yeah, unfortunately, I lost internet. So I'm gonna go ahead and finish my thought. And um, if you're still out there, then I'm glad that you stuck it out. And if not, then welcome back. Sorry, I lost internet. Had to reset my router, and took 5 minutes, a little bit more than 5 minutes for that to reset itself. So anyway, here we are again. Apologies. Probably most of you gave up after a few minutes, so that's what happened. Okay, Druid's still here. That's good news. I don't know where we. I saw the screen flash, and then I realized that internet had gone out. So hopefully it's somewhere kind of in the middle of my thought, which is a lab related thought, which is I'm creating this procedure to print an array. So I'm going to finish that thought, and then I'll finish up with the lab stuff, and then go have a peek at the project real quick. Yeah, Ember Wolf, I lost internet. We just don't have the greatest internet, as it turns out. So anyway, looking at you, Xfinity. Okay, so I was in the middle of kind of just showing you how I put together this print array procedure where as long as I know the size and the type and the address, I can print any array that I want to. I have to manually go do the work um, of figuring out the appropriate scale value and figuring out the appropriate typecasting value based on the size and the data type. But once I have the address and I have the size, then I can write a loop, and then inside the loop I'll switch between the different types, which will allow me then to code in the appropriate scale and typecasting. So I'm just going to do simple ones here. So this would be data type 1 is uns8. And now here comes my memory access. So I have the base and EAX. I am using ECX to compute sort of the standard style index, and then the scaling value. So you can scale by 1. It doesn't hurt anything, and I'm going to go ahead and leave it there. But of course, multiplying something by 1 doesn't actually have any effect. So for 8-bit things like uns8 in this case, you don't have to apply the scaling factor, but you can if it helps you remember that you need to do it for the bigger things. So I typecast to uns8, and then I scale for 1 byte, and then I'll do a couple more. So the data type is a type 2, then I'll just take this same code and make the appropriate adjustments to it. So that would be uns16. And then my scaling factor for uns16 would be 2 bytes a pop. I don't have to worry about the base address. That doesn't, nothing about that changes. I don't have to worry about the indexing part, because that doesn't change. It's entirely the scale and the typecast once I get going in here. And then just as an example, I'll do one more. So data type equals 3. These are based on my little invented coding scheme. So 1 is uns8, 2 uns16, 3 uns32, 4 would be int8, and so on. Then hopefully I still have that. I do. This would be uns32 typecast, so I get the proper presentation on the screen. And then be careful about the scaling factor. So this is kind of a cool thing because in a high-level language, unless I were doing templates, I would have to, which not all languages have. In a high-level language, there's a good chance I'd end up writing a separate print array function for all of the different data types of arrays that I might work with. So one of the things I gain at the assembly level is I can write kind of this generalized function with the logic in it that makes sure that I get the right scales and the right typecasts going. Anyway, so this is the example that'll go up on the lecture page. It's kind of hard to recover from losing the internet because I kind of lost my train of thought. Okay, so let me go grab the lab 12. Let me go grab the lab code. I still might actually come in under an hour and a half or about. So I'm going, you can't see me doing it, but I'm going to just copy the lab code. And let's see if there's any surprises before we look at the project real quick. Okay, so there are 3 different arrays. One of them is a character array, and then it's using this little HLA trick. So it says basically create a 10 character array by duplicating Z 10 times. So you'll get 10 Zs in your array. The second array is a 5 int 16 array with pre-populated data, and then there's an uns32 array for 3 elements, and it is all 0 values. It's not populated with anything particular to start. Okay, so we have a get char procedure. It is done. The get char procedure will use that to work with our char array, probably. Get int16 we'll use with our int16 array. And then get uns32, which no doubt we will use with our uns32 array. All those procedures are already written for us. And then go again is also written for us. Okay, so here's the print function. And notice address, size, uns32, and then a data type, which has codes that I just invented for the purposes of the lab. This push AD, what that does is it basically preserves all of the general purpose registers on the stack in one fell swoop. I did that in this case simply to completely free us from any concerns about wrecking any register that we might use in here. And then I pop AD, which is pop all of the 32-bit general purpose registers all at once. So yeah, Druid noticed that. Push AD means push all of the 32-bit general purpose registers on the stack. I don't know what order they are pushed in. It doesn't matter as long as you pop AD, which reverses the entire process. So this kind of just picks up and preserves and restores all of the general purpose registers for you in one fell swoop. The reason why we haven't used it before now is because I wanted you to understand what's actually going on in terms of how the stack works and in terms of what we're doing when we push and pop registers. But now that we have that experience, we can sort of use the safest option, which is push AD, pop AD in most cases. Okay, so anyway, same loop that we just saw. The index is done by the for loop for us. We have the logic tree inside of the loop that figures out what data type and uses the data type to figure out what to typecast and what to scale. So you'll repeat that process number 2. So you'll typecast to int16 and you will scale to, you probably know it, 2 bytes. And then this last number 3 is, in fact, I wrote it in the code. So one thing doesn't really matter, but notice in instruction number 1, I said use EBX for the base address. So if you do, be careful of that. Oh, actually you need to. Copy address into EBX. The reason why you should do that is because I've already written one that uses B for the base. Just because I felt like it, I guess. But anyway, you'll use B for the base. And then the scales. Those are all provided. You just have to kind of plug them in the right way in code. All right, let's see what the edit cell does. So the edit cell goes the other direction. So we get some data and then we copy it into the array at an offset. So one thing that I didn't do here, let's see, move, index. Yeah, so one thing I didn't do for the character is scale it, because the scale for a character is 1 byte. So that's why the scale wasn't there, is because you don't really have to do that. But anyway, so call get it int16 and then move AX to the array using the base address, the index, and the proper scale. And then this last one, you will call get uns32 and then move EAX into the array. Yeah, okay, so that's that one. This one is just calling the print procedure, passing address size and dtype. So I don't have to figure anything out. I literally just call print with the provided address size and dtype. Then call edit cell in the same way. So those are pretty straightforward. Let's see, what does 9 do? Okay, so I'll give you actually, I already gave you examples. Chars ints. So we print them. I edit. All right, so you do one more edit. So notice what I did for setting up the edit is I had to use the address of to get the address of the array into the procedure. And then I've supplied you with the other information that you need on the call, the procedure call. And then one more print all 3 arrays, which has already been done for us up here. So you could literally just copy and paste that. All right, so hopefully that's enough to work with that lab. The most of the kicker is just getting used to the weird looking scaled indexed addressing style. But you have a chance to kind of see, I've given you examples and then you repeat the examples and adjust them with the appropriate typecasting and byte offsets, scales, sorry, as appropriate. All right, so that's that. It's 226. So I do have a moment at least to switch over and let's look at project 2. Sorry we lost some time, but I'm not going to carry you over, basically punish you for it, for the lost 6 minutes. Okay, so project 2 is about doing stuff with arrays. Probably not a huge surprise. The one thing that we don't have yet is dynamic memory, but it doesn't matter. You can develop the entire program with statically allocated arrays and then replace the statically allocated arrays when we learn how to do that with dynamically allocated arrays. And that will be fine. So what I recommend that you do is you create an int8 array and just hard code its size. And then we will change it later to ask the user how big of an array do you want, and then we'll compute the proper size and allocate the memory on the fly. We haven't done that yet. So for this number 1, if you were to start today, just hard code like a size 10 array, int8 array. Then you don't have to worry about number 2 at all for now because we don't know how to do that. So if you hard code an int8 array, then you can proceed with everything from 3 on down. Everything from 3 on down. We'll have the option to populate the array with random values. We've done random values in the class, but it's not hard to find in the HLA documentation. But somewhere around like lab 2 or 3, we did random values. User enter values, you are doing that in lab this week, so that's a place to look for that. Display all the values in the array, that's the print function that we are doing this week in lab. The sum will take some figuring out how to do. We will experience this in an upcoming lab. So I'm not saying you have to do the entire project. I'm just saying if you go in here and look at the project, you'll discover that you can do parts of it. And you can do parts of it on a static array for now that will still be usable on a dynamic array later. If you look at the lab code, I'll just do it right here before I stop talking at you. Where's the print function? This print procedure doesn't care how the array got created, dynamic or static or otherwise. You give this procedure the address, the size, and the type, and it works. So you can start your project with static arrays. You can have this print procedure and others. And then you can later swap out for a dynamic array, and none of your procedures will have to change for that. So that's why I would encourage you to go ahead and have a look, and if not, get started. Okay, that's not a pretty screen to stop on, so I will stop on this one, I think. So apologies for the internet outage. I'm still on internet, yes. Thank you if you had the ability and time to be patient and wait me out until I returned. I appreciate that. It's going to be 2 pieces of video because of that, because I started a new stream. when I reset. So anyway, if you're looking for the lecture videos, there'll be 2 of them for this week, and I'll make sure that they're titled Part 1 and Part 2. I think that's it. So next week is a normal week. The week after that is a review week, where I will have a lot more time to sort of go back and say, here's what we've done that will help you with Project 2. So week 14 review, look for, if you are a Project 2 early starter, look ahead for week 14, where I will dive into that a little bit in terms of what knowledge and tools we have built up to this point to do the second project. Okay, I think that's it. Thanks again. Thanks for watching the lecture if you're watching it on video later. Canvas inbox, Piazza for questions, and of course the regular discussion, but you can always ask questions there, and a few people do. Office hours on Thursdays, as always, so please reach out if you're having any struggles anywhere. Otherwise, I will see you on Tuesday afternoon next week. Thank you, Isnam. You have a great week as well. Thanks, you guys. Thanks for sticking around through the outage.